where the trig and unit circle really starts getting good. Notice again, oh my goodness, these 30, 60, 90, and 45, 45 triangles will not go away. You're right, they won't. So I want to remind you what the patterns are for these before we go into how they relate to the unit circle, other than the angles, of course, from yesterday's video. So, if you may recall, across from the 30-degree angle is our smallest side, so we called that x. The medium side across from the 60 was x times the square root of 3. And then the longest side, the hypotenuse, was 2 times the smallest side, or 2x. In the 45, 45, 90 triangle, we had 2 legs that were the same length because of these angles, so we called them both x. And then the hypotenuse was x times the square root of 2. I don't remember if I said this the last video. Remember, something that I do to remember if it's the square root of 3 or the square root of 2 is this one has a 30-degree angle with a 3, so the square root has to have a 3 in it. This triangle has 2 congruent sides, so the square root has a 2 under it. That at least helps me remember for a good memory trick there. Now, what do these triangles have to do with the unit circle? Well, there was a definition on the last video that said that the unit circle is called the unit circle because every radius is only 1 unit long. It's made specifically and artificially so that your radius is 1 unit long. So all of those angles we talked about yesterday, our longest length we can get to is 1, which actually helps us because that means in our ratios here that we can say that x is actually just 1. So if I wanted to write my triangles more simply, instead of x, I could write 1. Instead of x root 3, I could really write 1 root 3, or just root 3. Instead of 2x, I could write 2 times 1, or 2. So a 30, 60, 90 triangle is in the ratio 1 to root 3 to 2. And if I drew this triangle the exact same direction, if we're thinking that the radius is 1, in this case x kind of goes with that because we're talking about this distance, instead of x and x, we could write 1 and 1. Instead of x root 2, we could write 1 root 2, or really the square root of 2. And so our ratios would be 1, 1, and root 2 if we have a radius of 1. So yeah, that's why they call it the unit circle, because literally you're talking about 1 unit in each direction. Now, how do these special right triangles help us on the unit circle? Before we get there, I'm going to recopy for the sake of visual. 1 root 3, 2, 1, 1, root 2. And I want to take every single situation separately. I first want to talk about 45 degrees, or pi over 4. Next, I want to talk about 30 degrees, or pi over 6. And lastly, I want to talk about 60 degrees, or pi over 3. A lot of you might have noticed or discussed in class that 45, 30, and 60 degrees are reference angles on your unit circle, meaning every other angle is some kind of multiple of 45, or some kind of multiple of 30, or a multiple of 60. So what I want to do is draw a triangle on my unit circle, which I did briefly in the previous video. Now this is my 30, let me erase that. I'm doing 45 first. So this is my 45 degree angle, and what I want to do is make a right triangle. So I want to drop a perpendicular down to the x-axis and draw a little right triangle. My reference angle in this case is 45 degrees, so I'm going to put a little 45 there, or pi over 4. And my goal of this triangle is trying to find that coordinate point on the unit circle. So from the last couple videos, we were talking about sine, cosine, and tangent, how they relate to x and y values. And I want to write down here that cosine really has to do with an x value more because cosine is moving on the x-axis. And then sine we talked about was much more of a y value. So if we found the cosine in this triangle based on that angle, and we found the sine of this triangle based on this angle, we would know what the horizontal and vertical distance is, and we can find the coordinates of this point right here. So let's find the cosine. The cosine of theta if I want to be more specific, instead of saying theta now, we are really finding the cosine of 45 degrees and the sine of 45 degrees. The cosine of 45 degrees, if we take a look at this triangle up here, I'll use this as a reference, would be 1 over root 2. The sine of 45 is also 1 over root 2. Both of these can be rationalized to be root 2 over 2 and root 2 over 2. So if you're thinking about what is the coordinates of that point, well, we went root 2 over 2 units for the cosine, and then we went root 2 over 2 units upwards, which was related to sine, which means if you're thinking this is your x value and that's your y value, my coordinate would be positive root 2 over 2, comma, root 2 over 2. And I have good news. After you find one of those points, or once you have that memorized, you can find the other 45 reference angle positions easily based on sine. We knew that these would both be positive because they're in the first quadrant. If I go to the second quadrant, it's the same triangle with the same reference angle, but the signs are different. The x is negative and the y is positive. So my point would be negative root 2 over 2, comma, positive root 2 over 2. In the third quadrant, we have two negative values for x and y, so we'd have this point being negative root 2 over 2, comma, negative root 2 over 2. And this point in the fourth quadrant, x is positive, y is negative, so it would be positive root 2 over 2, comma, negative root 2 over 2. So what's really useful is starting to really get ingrained that when you see cosine, you're really considering x. When you see sine, you're considering y, and they help you with this special right triangle to find all the coordinates all the way around your unit circle. Time to figure out the special coordinates for the 30 degree. So what I'm going to do is draw the little triangle with a reference angle of 30 degrees. And so what I'm going to do right above here, because the orientation's a little different, is I'm going to write 30 here. So this would be our 1. If this is 60, this would be our root 3, and this would be our 2. Because here the 30 was on top, but now 30 here is on the bottom. So we have to be careful about the order. So again, if we want to find out what this point is, we need to think about x distance and y. And the x distance and the y can be found by finding sine and cosine. So let's focus on finding the cosine of 30 degrees as well as the sine of 30 degrees based on this triangle up here. If we look at 30 degrees as a reference, the cosine is adjacent over hypotenuse, which is root 3 over 2. And the sine of 30 is opposite over hypotenuse, which is 1/2. Which means in my little triangle, this can be represented by root 3 over 2. This could be represented as 1/2 in the unit circle, which means that this point, x comma y, is root 3 over 2, comma 1/2. And so yet again, makes sense these are both positive because it's in the first quadrant. But now if I think about reflections and I look over here, this is in the second quadrant. X is negative, y is positive. So we'd have negative root 3 over 2, comma, positive 1/2. Notice in the third quadrant, if you draw a straight line, this angle is going to go with 30 as this reference angle. Both quadrants coordinates are negative. So you'd have negative root 3 over 2, comma, negative 1/2. And then if we follow the straight line here, this point also goes with this point, which goes with this reference angle. X is positive, y is negative. So we would have positive root 3 over 2, negative 1/2. So these are the special points from the 30, 60, 90 triangle. Last but not least, we'll do the 60, 30, 90 triangle. And let me draw it first. This is my 60 degree. Drop a perpendicular. 60 here is my reference angle. And just for the sake of making this a little easier to see, I am going to erase the 30, 60 one we used before. and I'm going to redraw it in the exact orientation that I need it. So here, I'll do it again in purple. We have our 60-degree angle down here. So this would be our 30. And according to the relationship, across from the 30 is 1, across from the 60 is root 3, across from the 90 is 2. So let's focus on finding cosine of 60 and sine of 60 degrees. Cosine of 60, if you use this as your reference angle, cosine would be adjacent over hypotenuse, or 1 over 2. Sine of 60 would be opposite over hypotenuse, or square root of 3 over 2. So notice that the square root of 3 and the 1 over 2 and the 1/2 are repeating over here, but in a different order because you're using a different reference angle. So this point, if you're thinking x comma y, would be 1/2 comma root 3 over 2. And then if we continue with sines, the reference angle that goes with this, if you think again reflection, x is negative, so negative 1/2 comma positive root 3 over 2. This in the third quadrant would be negative 1/2 comma negative root 3 over 2, and straight line here. This coordinate would be positive x, 1/2, negative y, negative root 3 over 2. And so eventually, we're going to be able to put all of these together into one unit circle so that we can find a lot of information about a bunch of coordinates. And so the more, again, that you practice these, the better. But notice, a lot of students have an easier time remembering 45/45s or the pi over 4 because all of these are root 2 over 2, depending on sign. The 30/60s and the 60/30s, notice, are all root 3 over 2 and 1/2, but the order matters. As a suggestion, based on teaching trig in the past, I would maybe consider memorizing that sine of 30 degrees or sine of pi over 6 is 1/2. Because if you know that sine of 30 is 1/2, or in other words, in radians, sine of pi over 6 is 1/2. So in this triangle, for instance, if you know that sine of 30 is 1/2, you automatically know that the y value is 1/2, which means that the y value would be 1/2 in every single situation. So if you're willing to memorize this, it'll help you with both of these cases. How does the unit circle relate to sine, cosine, tangent, cosecant, secant, and cotangent? Well, we've already talked about that in this video, but to make it organized for you. Really, the reason I asked this question was to reiterate sine. When you think about sine on the unit circle, please think about the y coordinate. When you think about cosine on the unit circle, think about the x. So actually that would mean, before I go to tangent, that cosecant is the reciprocal of sine. So this is really 1 over y. The secant is the reciprocal of cosine, so that's 1 over x. If I go back for a second and think about tangent, if I compare tangent, like if I looked at this middle triangle and I think about tangent as opposite over adjacent, opposite is really y and adjacent is really x. So tangent is really the comparison of y over x, which some of you may remember from before. So cotangent is the comparison of x divided by y, or x to y. Knowing these and practicing these, again, is something that'll really help you with speed as we start using the unit circle more and more. So again, tomorrow we're going to be practicing putting these coordinates on the unit circle, kind of starting to memorize them and get them down. The faster you have them memorized, the more you practice, the stronger you will be. Again, thank you for your time, guys. Good luck tomorrow.